this is the border of Austria, and this is Italy, and that is the Austrian and Italian border. And in 1991, a Neolithic corpse was discovered exactly on that border. And it was at this point here. And this was the famous Iceman, the Ötzi. These several photographs are by a friend of mine, Reinhold Toder, who's a mycologist in Austria. And when the tourists discovered that this body was present, they got a hold of the local constable, the local law enforcement, and in Australia, in Austria, they said, "Oh, we found a dead body." And the Austrians said, "We find dead bodies all the time. We'll go up and see them later. See it later." Well, the tourists realized, no, this is really something significant. So they dragged the body over the border into Italy, and the Italians met Ötzi and said, "The father of the Italian people, you've come back." And that created a huge international incident that some of you may know about. Well, Ötzi was eventually repatriated back into Italy, and so there he resides today. He was the best human remains ever found in a non-funeral state, in a non-funeral preparation. He died standing up, he had a spear point in one of his ribs. But he had tethered to his right side 2 polypore mushrooms. One of being, which is Pt.2, the birch polypore, and the other one is Amadou, Fomes fomentarius, of which my hat is made from. And this is the actual fiber he had in his pouch. And Dusty and I were given actually a piece of this fiber as a gift. So we actually have a piece of the Iceman's fiber that was contained in this pouch. Extremely flammable material. This is why, if people were smoking cigarettes, I don't want them near my hat, because they catch on fire and burn up. But that was so essential for his survival that he tethered to his right side. Most of us who are right-handed, if you have your keys, you have your knife, you have the items of most importance ready at hand. And so did the Iceman. When we look at ecosystems, we now understand that they're infused with huge communities, guilds of fungal cultures in mycelium. So we look at a habitat cross-section. There are parasitic fungi that can kill trees. There are saprophytic fungi that they grow on dead organic material. Some parasitic fungi can grow as saprophytic fungi. There are the endophytic fungi, an extraordinary group of great biodiversity that is now really taking the field of mycology by storm. This research really came out after a group of scientists walking around the boardwalks around Old Faithful at Yellowstone saw plants growing in the hot pools of water. And there are grasses. And they pulled the grasses out, saying, "Oh, thermotolerant grasses growing in water up to 150 degrees Fahrenheit. Scalding hot temperature. The grasses were thriving." They pulled the grasses out, they brought them into the laboratory, they put them into petri dishes, they tissue cultured them, they got a mold, and they got the grasses growing. The scientists said, "Oh, the mold's a contaminant." Very common. It's understandable why they would think so. So they separated the mold away from the grasses. They grew the grasses up. They put it into the same ecosystem, raised the temperature of the water, and all the grasses died at 105 degrees. One of the scientists said, "Well, that mold that we keep on seeing every time we try to culture these grasses may not be a contaminant. It may be a companion." So when they joined the companion of this fungus called Curvularia back with the grass, and then they grew up in the laboratory, all the grasses survived up to 150 degrees. So they found that the Curvularia fungus, as an endophytic fungus, gave thermotolerance to a plant. Now this is hugely significant. Corn is a grass, rice is a grass. So the idea of being able to get thermotolerant foodstuffs growing in areas that are increasingly suffering from desertification and from climate change is obviously very, very important. So when we fast forward to about 4 or 5 years ago, it turns out that Curvularia also co-associates with many other plants, including tomato plants. So tomato plant research breeders thought, great, let's see if we can get Curvularia from Yellowstone, put it into the tomato plants, and grow up thermotolerant strains of tomatoes. Well, it makes good sense. And so they ordered the culture from the American Type Culture Collection back east, which stores the largest reservoir of plants and algae, protozoa, fungi, in different cell lines in the world. Stored in liquid nitrogen, extremely cool. When they got the culture from the American Type Culture researchers are going, your fungus no longer seems to give thermotolerance to plants. And the researchers who originally deposited that culture go, this is very strange. We don't understand. Fortunately, they kept some petri dishes on the shelf in the laboratory that they never put under liquid nitrogen. And they discovered, upon analysis, something absolutely unprecedented in the history of science. That within the curvularia fungus stored at room temperature, there was a previously unidentified virus. And the virus inside the fungus, and the fungus and the virus inside the plants, as a trilogy of 3 different forms of life. Viruses, you can argue, are not forms of life, but 3 of them coming together gave and conferred thermotolerance. Now this brings up some very interesting ideas. It's an argument, I think, for eating foods bioregionally in the ecosystem in which you live. How many beneficial viruses are there that we know? Extremely few. And that these viruses that are endemic to the foodstuffs and the plants that are indigenous to the communities and the environments that we live, I think are conferring to us a climatic adaptation that helps us to adapt. So my good friend Andy Weil, when he comes from Tucson, Arizona, comes up to this environment, most of us would consider this temperature outside kind of hot. You know, people from Thailand, people from southern Arizona, they come up here and they go, it's incredibly cold. Well, I think there's something going on here. So I think this should be explored to a much deeper level. Another group of fungi, of course, are the mycorrhizal fungi. I think most of you know about this. 90% of all plants in the world have mycorrhizal fungi. There can now be identified over 200 endophytic fungi that are growing in the leaves and needles of trees. And at the base of a Douglas fir tree, there can be more than 120 mycorrhizal mushroom species that course through the roots of the tree over the entire lifetime of the tree. So, an excellent book by Smith and Reed is Mycorrhizal Symbiosis. Here is the root of the small pine. This is all mycelium of ectomycorrhizae, of mushroom-forming fungi. Here is a root zone from my friend Steve Morris, and the root is now, as a lot of moisture, and the mycelium is surfacing to the very top of the ground. So my wife Dusty and I spend a lot of time in the old growth forest. This is where we like to say we go to church on Sundays. And in the old growth forest, it's much more complex of an ecosystem than scientists just thought just a few years ago. Another group of scientists, Arnerbrandt and Samard, 1994, 1996, were trying to understand how is it that these hemlock trees growing in nurse logs, which is an indication of an old growth forest, could have enough light to photosynthesize. When they took the hemlock trees and took them into a greenhouse environment, provided the same amount of light that's typical in the old growth forest, all the hemlock trees died. So they said, how is it that these trees are being able to survive? And so they radioactively tagged carbon and nitrogen, and they discovered something, again, unknown in the field of science, that alder trees and other types of deciduous trees, but I use alder as an example, alder trees would transpose nutrients over hundreds of feet to feed the developing hemlock trees, a deciduous tree feeding a conifer. And there's a bidirectional flow of nutrients mitigated by the mother mycelium throughout the entire ecosystem. This is our first beginning of our understanding that these fungi guarantee the biodiversity and the plurality of the organisms within the ecosystem, because that ecosystem then had resilience to catastrophe. And by doing so, it guaranteed that population and the biodiversity for the benefit of all. So this has now really changed many ecologists' thinking and understanding